Hello and welcome to Module 1 in Big Data Technologies. So we'll start off with a module overview and then we'll kind of go from there. So in this module you're talking about solving problems with MapReduce. So the first thing you may ask yourself is, well, what is it, right? So what is MapReduce? And it's a framework that basically makes it easier for people to write distributed programs. It's basically what brought the whole big data pattern into existence. The reason it's used is because it simplifies the development of essentially parallel programs. So whenever you're dealing with distributed processing, it's as we say, non-trivial. It is challenging, can be quite challenging to accomplish. And so the MapReduce pattern simplified that process by basically having people develop essentially two constructs, and we'll talk about them in a little bit, but basically you do some mapping, you do some reducing, and a lot of magic happens in between that you don't know about. It's commonly used or was used in log file analysis, text analysis of some sort, and sometimes around data movement and refinement. I say was because it's less commonly used today than it once was. It sort of was great getting us started. We've kind of moved on to some other things since then. So some key terms, Hadoop and MapReduce. So we talked a little bit about that. Hadoop we'll go over here in a little bit, and as well MapReduce. Parallel programming, that's another one where basically things are happening concurrently across different computers in a distributed fashion in this case. Parallel could just mean that it's happening in multiple threads of execution, but we generally speaking talk about things in a distributed fashion, so across different computers, not just across different threads, across different cores in a processor. HDFS, Hadoop Distributed File System, is a way of handling this distributed processing, storing large amounts of data on commodity hardware. And then there's kind of these types of data that you'll oftentimes see. You'll hear people talk about structured, semi-structured, and unstructured. It's kind of a continuum. On one end, you have things that are very structured, very rigid. And this is things that typically have a schema, typically something that's potentially started life in a relational database of some sort, or relational data store. Generally speaking, you have this concept of rows and columns. There are variations on that theme, but that's the basic idea, is that it is essentially something that is tabular in nature and rigid and strongly typed. Semi-structured, kind of between the two. It's things that are typically well-formed or structured, but there's often room for some grayness in that. A good example of that is something like XML or JSON. And JSON being the format that is much more popular these days for exchange than XML is, although XML is still relevant. And then unstructured is basically, it's just a free-for-all, right? It's things like free-form text, images, audio, anything that's not something else, right? So if it's essentially just a blog post, probably not semi-structured or structured, but it's typically going to be viewed as unstructured. A stream is also very relevant in this world, and it's essentially an unbounded table is the way to think of it. So it's a continuous flow of information between devices or files or something, right? So it's essentially things that don't necessarily start and stop. It may run continuously and flow continuously. The alternative to that is obviously batch, or the kind of between the two is this concept of a micro batch or mini batch. Basic idea there is with a batch process, things start, they do some stuff, then they stop. And that's where MapReduce and Hadoop typically plays a lot of the time. Hadoop being kind of the foundation for some of this stuff, so it very well could be that Hadoop is being used also to do some true stream processing as well. So how did we get here? And Hadoop started long ago. It actually predates the MapReduce paper that Google wrote, because there was this project called Nutch that was back in 2002, if you believe it. And so the idea there is that it was the history of why it is, it doesn't matter too terribly much, but the person that created it ended up basically creating the first kind of versions of Hadoop. So the idea that Google, and there's this pattern in the big data world and open source in general, somebody writes a paper that describes something they've done internally, and then the community as a whole goes and creates something that does similar to what the paper describes. In this case, we're talking about Google File System was written in 2003. That laid the groundwork for HDFS, so the Hadoop file system. Google never open sourced their file system, but they did describe it in enough detail that somebody could create an open source version of it. And also the same thing is true of MapReduce. And that pattern is reoccurring across lots of different open source projects. Somebody writes a paper, somebody goes and implements it. So Doug Cutting, so basically what was in Nutch became MapReduce, right? So he essentially moved it over into the Nutch project, implemented his own version of things. It's not a GFS by any stretch, but it's based upon those concepts from the paper. And so on. So the next thing was that it actually became a Lucene project because Cutting went to work for Lucene. And then in 2006, another sort of a pattern that we'll see, Google wrote about Bigtable, the thing that inspired HBase. So essentially similar sort of patterns. They wrote it in enough detail that somebody could implement it, and so on. 2007, we had a 1,000-node cluster running at Yahoo on Hadoop. And then at 2008, Apache made Hadoop a top-tier project. And then a few other things along the way, and we're up now to, I think, 3.31 of Hadoop. So been continuous development, although interest in Hadoop has kind of waned of late. And we'll talk about that later on. But that's how we got here. A revolutionary concept. And the basic idea is to build software that runs on commodity hardware. So before things like Hadoop and similar sort of concepts, if you wanted to do that scale of processing of 1,000 nodes in a cluster, you were a government agency. Or maybe a really big company. But what Hadoop let us do is go out and buy basically off-the-shelf components that are moderate tier. They're server class. They're not your home computer, but they're not high-end specialized computers either. Hook them up in a certain way so that software handles failures that are inevitably going to occur. And it allows you to basically have things at a much larger scale. Also combined with that was the concept of making the access to that software, including the source code, free. So open source allowed for rapid expansion and a creation of an entire ecosystem of tools. And we started Hadoop 2 and Hadoop 3. This is where things really started getting interesting, especially with Hadoop 2. Hadoop 2 introduced this concept of essentially having a separate scheduler, Yarn. And also HDFS and MapReduce. So it was basically that kind of magic combination. And so that's led us to where we are today, where there's basically an ecosystem. Interestingly enough, a lot of these first-class Apache projects are no longer there. They're being kind of phased out over time. It's part of kind of the life cycle of this sort of thing. So breaking down exactly what is Hadoop, it starts with a file system. So just like Linux or Windows has a file system that you interact with if you want to store files, same sort of concept. Again, though, it's distributed. It allows you to have files stored in redundant locations so that if one of the nodes goes down, you're able to recover that lost information, and also allows initially for processing to occur close to the file, which was important back before we had fast networks. It also allows you to do distributed programming. That's where things like MapReduce, Hive, Pig, and Spark come to play. Spark has since kind of done a lot of the workloads that originally might have been inside of MapReduce, primarily because it is a whole lot faster. It also really is fast if things can be kept in memory. You also have this concept of NoSQL databases, HBase being a common one. There are others as well. concept of ingesting data, so Flume, Scoop, and Storm, and Storm also being potentially in the world of stream processing, which isn't necessarily spelled out here explicitly here. Zookeeper for service programming, scheduling is Oozie, machine learning, Mahout, and system deployment and Bria. So lots of different things, and this is just some of the Hadoop sort of systems and components in that ecosystem. So when we talk about MapReduce and how did we get here, the whole point of MapReduce is that you basically, as a developer, created essentially the mapper and the reducer. And what it allowed you to do was focus on a very simple operation, which is how do I kind of extract the text that I care about and get it into a format that I can work on it? And then can I combine it together once some magic has been done to it or some processing has been done to it? And that's where the idea that there's this whole shuffling that goes on and copying and merging and all this stuff, you don't necessarily care too terribly much about it. It kind of does it for you. That's part of the beauty of this, is you have a series of files distributed across your cluster, and each individual node picks up the files that are close to them, is the idea, does the mapping, then sorts them, sends them out to the appropriate other nodes so that they could then be merged together and then reduced and then produce the output. So a classic example is counting things. There's actually a reason to do this. Counting words is a common pattern in certain scenarios, especially linguistics and natural language processing. We actually have this concept of a bag of words, and frequency of words may matter in certain situations. But regardless, it's kind of the hello world of MapReduce jobs. It starts by you basically split the file into a series of lines. You then, in the map operation, count the number of words. Then you take the shuffle sort and essentially get the words together, and then reduce by summarizing the words, so adding up the individual ones, and then you produce your final output. And that's the general pattern. So we'll go through a little more of that in a moment, but I wanted to kind of lay the groundwork and then start talking about deliverable 1. So your first deliverable is a paper, right? So the competency that you're demonstrating is the ability to apply the MapReduce paradigm to solve a programming problem. Take a look at the rubrics as always, and we'll talk about them here in a moment. You work for Big Data Connection Inc., BDCI. It's an international data clearinghouse that provides data services to thousands of its customers. As a data scientist for BDCI, you have been given the assignment of explaining and breaking down the MapReduce process using Hadoop. This assignment is critical because BDCI's upper management has several clients that are questioning BDCI's ability to parse their massive amounts of semi-structured and unstructured data in a timely manner. As a leader in the field of big data, you rely heavily on the capabilities to provide easy to comprehend synopsis of how the whole MapReduce paradigm works, and how it can process massive amounts of data. Your manager has tasked you with creating a presentation for the clients that have that have a limited technical background. The results of your work should be put into BDCI's skeptical clients at ease. So you're basically explaining to them so that they can understand what it is. So you're going to present a Word document as a white paper. You'll probably follow a certain amount of APA formatting, but APA doesn't necessarily have the concept of a white paper. So I will be fairly lenient on what the formatting actually looks like, although it's probably a good idea to do APA citations. In as far as the actual other elements of style, I'll be pretty generous. So you basically are to describe the process of how a program utilizes MapReduce to divide data into segments, and then process those segments, and then ultimately reduce them by assembling the comparable set of data. So basically, how does it go back together? Your description should not include code, so don't do code, even though I'm going to show you some code, hopefully here in a little bit. That's more about deliverable 2, because deliverable 2 has historically been quite challenging. Your white paper will define the following terms and functions and how they relate to MapReduce. So talk about what a map job is, what is a tuple, what is a reduce job, how does a relational database management system compare and contrast with Hadoop, what is parallel processing, what is a UUID, and that's kind of out of the blue there, right? But it is relevant because unique identifiers and sequential identifiers are a challenge in the big data world. You can't do something like what you might be used to doing in traditional database, where you have an identity column in your database and it sequentially issues keys. It doesn't work in a distributed world because you would have to bottleneck, right? You'd have to lock something down with some sort of single thing issuing those IDs, greatly reducing concurrency. So UUIDs kind of is what you do to replace that. You might want to take a look at the various types of UUIDs and maybe think about, what does MD5 have to do with the UUID, and is it relevant? So then, in addition to your paper, you're to create a PowerPoint presentation that aligns with the content of your white paper and includes a graphical representation of the entire MapReduce process and an example of how MapReduce works with data. So you've got two deliverables here, a document and a PowerPoint. Some resources are located inside of the course room, and feel free to use a few other references beyond these. So your first criterion, as always, you shoot for that left column. So basically, a thorough and detailed white paper has been developed with an explanation that describes the process of utilizing MapReduce to divide data into autonomous segments and process the segments and ultimately reduce them and producing essentially your output. No errors, does not use examples of code as part of the paper, so no code. The second criterion, the white paper contains a thorough and a detailed definition and explains the application of the following functions and how they relate to MapReduce. In particular, map, what is a map job, tuples, map a reduce job, how relational databases are different from Hadoop processing, what is parallel processing and UUIDs, free of errors, does not contain any code examples. Really don't want to see code here, apparently. And then your last criterion is a thorough and detailed PowerPoint presentation that aligns with the white paper, contains graphical representations and the entire MapReduce process, the example of how it works with data. The PowerPoint is free of errors and does not use examples of code as part of the presentation. So again, no code. Code is in the next one. In preparation for that, historically, the first deliverable, people nail. I sometimes do a poor job explaining the second deliverable. The second deliverable gives you it specifies that you should create a single node cluster in HD Insight in Azure. There's a couple things wrong with that. You can't really create a single node cluster in HD Insight. That's the first thing. There's going to be more than one node. HD Insight is problematic because it's expensive. So whenever you start looking at the instructions for deliverable 2, you'll be told repeatedly to delete your cluster if you're not using it. The thing with it is that creating a cluster takes 20 to 30 minutes or longer sometimes. And deleting one's not fast either. The reason that we care about that is that unlike many cloud resources, HD Insight, you pay while the thing exists. So as long as that cluster exists, we're paying for it. And in turn, at the end of the day, so are you, right? As the students at this organization, you're the ones who are paying for it. So an alternative, and this is something I've offered students in the past, is you can do it in a different way. The point here is to have Hadoop running, create, do word count or some sort of MapReduce program, and talk about the results and the experience. So that's kind of the intent. We'll get into it more next week, but that's the basic idea. So to start off with that, and I don't know if I'll get through it all today. I may be picking it up on our Thursday session. An alternative that I may actually encourage you to look into and hopefully this is big enough, but because of it's hard to make it larger in this particular situation, is there's this concept called the Windows Subsystem for Linux. We're actually up to the second version of it, and it's kind of cool. What it lets people do, if you're running on a Windows environment, then you can actually install, in this case, Ubuntu 18.04 LTS, and it runs almost as fast as though it were running on native hardware. It's really close, and it's not doing this through virtualization with a VM or something, although it kind of is virtualization, but it's doing it at a much lower level, and it's highly integrated into Windows. It's available both Windows 10 and Windows 11, and definitely a viable alternative for this particular assignment. So that's the reason why we're talking about it, is a way that you might want to do Deliverable 2. Other alternatives, and I'll talk about them next week, will include maybe using a virtual machine. That's a valid one, either a virtual machine running locally and something like VirtualBox or whatever, or a virtual machine running in Azure is a viable alternative as well. The thing I'm trying to do is give you alternatives so you don't have to fight HD Insight unless you really want to. So I don't want to make it sound like it's an insurmountable task to go that route. This is something, though, that might be a little easier. One of the things I've done to make it easier yet is I've actually put a script up in my GitHub account, and I'm looking for the right window so that I can go there. So if you go to GitHub, Alan at Rasmussen, spelt out, /data science. Data, not the best project name, I know. And inside of that, there's a folder called Hadoop. And if you clone this, you'll thank me later, because this is basically what you need to go through the process. And in fact, what we'll do next is start working through these the steps. So the Hadoop install is inside of this. Let's see if I can make it a little bigger. Inside of this Notepad++ file, and it basically contains the steps that you go through to get this up and running. So what I've done to kick this off, I went ahead and saved some time. If you go into the Microsoft Store and search for Ubuntu and pick either Ubuntu 18 or 20 LTS and install them, and you may have to turn on Windows Subsystem for Linux. Again, I'll talk more about this later. But once you've turned it on, and it even tells you here, turn on Windows features, select Windows Subsystem for Linux, and click OK, and then reboot, and then you can use this app. So you basically install this just like any other app that comes out of the Microsoft Store. And whenever you run it the first time, it asks you for a Unix username. And so I'm going to be terribly creative and type in my name as the username and a super secret password. And so we now are at a Unix shell. And then start working our way through that script that I gave you. The first thing you'll want to do is do something as sudo a time or two. So this allows you, whenever you run things as sudo, it's running as super user, right? And that super user do is what that stands for. Once you've ran it the first time, then you're able to copy in more than one thing. So basically what we're doing here is doing an update, and then the whole point of this is to get Java installed, because spoiler, Hadoop uses, and MapReduce uses Java. And in fact, that's probably part of why it's not quite as popular as it once was, because in order to write a MapReduce job, you've got to write Java. That compares to things like if you're using Spark, you can write your Spark jobs in Python, SQL, Scala. You can do Java if you're so inclined, but most people don't. And even R, you can write your Spark jobs using R. So the basic idea there is that you aren't locked into having to do it with one particular language. So here we're going through and basically installing the the default JRE, then install an OpenJDK 8 JRE headless, and then install an OpenJDK 8 JDK. So the idea here is just to get Java installed because life is much better with it. And this is just making sure. It took me quite a while to get these set of steps down, so you may want to use them. Even if you were to do something like install it inside of your own Linux machine, these in Lineage would make it pretty easy for you. The longest thing you do here is wait for things to get installed. And to that end, I've actually will be doing a little cooking show trick here in a little bit, where we copy a previously downloaded Hadoop version rather than waiting for that to finish. So at this point, we're basically going through another 30 seconds or so and putting OpenJDK 8 on headless right now, and then we'll do the OpenJDK 8 JDK, which I think is fairly quick. And again, we'll talk more about this next week. I just wanted to lay the groundwork so that you're prepared for deliverable 2. The first deliverable, pretty straightforward, right? It's just a paper and a PowerPoint, not terribly scary. And you'll notice here that we're running in a command shell. You can actually run graphical applications inside of the Windows Subsystem for Linux as well. What they've done is blurred the lines between Windows and Linux with these products. I can interact with Linux from a command prompt and so on. I can do, if I go into Windows Explorer, I can actually scroll down here to inside of Linux, and I can actually go into the file system of this machine that we're using, right? So it's a seamless sort of integration. So now that we've got Java installed, the next step is to get SSH working. A test is to see if you can do local, or you can do SSH to localhost, right? And it doesn't work because we have to do some stuff first. The reason we have to do this is because Hadoop relies on SSH as the communication mechanism, and SSH is basically kind of somewhat related to Telnet. It's a way of sending textual commands across the internet to a server. It happens to be that the server is running locally in this case, but it works if you were hitting it in a remote location. So if you actually do the HDInsight route, you will be talking to HDInsight over SSH. The way to get this to work that I found the most consistent is to, in the case of getting it working inside of Windows Subsystem for Linux, is to remove it, then add it, and then go through these steps of creating a key, so an SSH keygen, essentially copy that over to an authorized keys location. Then we change the attributes on it, and then if life is good, we do a start of that service, and it starts up, and then I can do an SSH localhost. And it's at the point it asked you, do you want to do this? Do you trust this fingerprint? And you say yes, and then it lets you in. You know you're working. So we're actually, even though it looks like the same prompt, we're actually kind of almost like logged back into ourselves, so we can exit out of SSH and we're back to our terminal. So that's one of the key challenges, is getting SSH to work. Once you get it working, the next step is you're going to want to get the Hadoop distribution on your computer. I'm going to cheat and copy it from a location where I've previously done it. And what that did is copy it over inside of this directory. That's what that file Hadoop, whatever, Hadoop-3.3.0 is. What you'll want to do otherwise is a wget. So this is the command that you'll want to run. So wget, and the -nc is no clobber. And what that basically means, if the file exists, then it won't overwrite it. Since it's already exists, it's going to say it's already here. I'm not going to go get it. So Otherwise, it's going to take you a while to download it because it is relatively large. So once you get it, the next step is to expand it out. Tar is what does that. It's very similar in nature to like an unzip sort of thing. And at this point, we're basically spreading it out onto our file system. And the next step when this finishes is to go into that directory that it's actually creating. So now we can do a print working directory, see where we're at. I'm in my home directory. I'm going to switch down into that directory that was just created, this Hadoop 3.3.1. And we can see this is what Hadoop looks like. So maybe not that compelling. Your next step is to go down into etc Hadoop. And the idea here is you need to edit some files. So if you were doing this yourself, you would go through, and this is to set it up so that it'll work with a what's called a pseudo distributed cluster, right? So it's a single node cluster. We can actually do that inside of this environment. And what we do is we have to comment out a few things. I make some comments of them, and then basically we can download some files that I've previously figured out, right? So if you really want to pick apart what I've done, feel free to do so. Or you can do this, which is basically I'm making a backup of the core-site.xml, and then I'm going to do again a wget this time and pull it down from my GitHub repo, and that just created the file that we're moving over, or it is creating it. And we do the same thing with hdfs-site.xml.backup. And these are relatively small files, but it's easier to do this than to go through and edit them, because inevitably, whenever I edit files anyway, I'm horrible at following directions. So I'll typically miss something. I'll do something twice. I'll do it in the wrong order. So if I do something with automation like this, a whole lot less chance of it going badly. The last bit here is to set up the Hadoop environment so that we can basically do things inside of it. And that's what we're doing here. And so now the next step is to basically get back up, higher up in the tree. And we're up to the Hadoop 3.3.1 folder. And so what we're going to do next is add some values into our profile so that when we log in, they should be in place for us. And that's what this echo does, is echo, and then I'm saying set Java home equal to where Java is. I need to fix that right there, because that's probably part of the problem. 3.1 is what I'm using, not 3.0. So earlier I had trouble with Hadoop home, wasn't necessarily working. So here's a good example of using code. Visual Studio Code is a kind of free version of an editor from Microsoft, inspired by Visual Studio, but it's a different paradigm, much closer to something like PyCharm or some of the other kind of open source based editors. The distinction being it's very much directory oriented. It's about being able to edit files, not about solutions and big projects, generally speaking, much simpler things. What we're doing right now is installing a piece of code that runs inside of Linux. But at the end of it all, what will happen is I'll be able to type in the command code, and either the file that I want to enter or edit, or a particular directory that I want to edit, and I can edit that inside of essentially Windows using native Visual Studio Code. And it does so through some sort of a proxying sort of communication pattern. How it all works, it's magic, right? We don't care. But what is cool, though, is that you can use an editor that you're used to using rather than having to use something from the last century, such as Emacs or VI or some other less than robust editor. I guess is downloading it it's a one-time operation. Once it's done, we'll be able to edit it. And the good thing here is that we're almost done, assuming things actually work for us. So the next step is to actually start up Hadoop. And so that's what I'll go ahead and, well, I guess I'll give it a couple more minutes. It's not that far away. So the next step will be to run these commands. So we're going to potentially source this profile that we're doing. That's a way of making it essentially take control. Yeah, see, here's the problem. So what we did now is I'm editing. This is inside of Windows, right? I'm to the values. I didn't bump the version number because files that you see in GitHub are from Hadoop 3.3.0. 3.3.1 has been released, so I'm installing that this time. So that is what Visual Studio Code looks like. So our next step is to run these next few steps. And we'll see how this goes. It's always interesting. So the next step is to try to do source the profile, and unlike DOS, set doesn't seem to just dump out the values. There's a lot more interesting stuff going on inside of my shell. So I was hoping to see, how about we try a different way? Echo, yeah, echo, $, squiggly, Hadoop, home. Okay, so there we are. So the next step is to go ahead and do some exports here. And then with any luck, so and it's always fun. So sometimes the easiest thing here to do is to exit out and come back in, and that also let me show you the Windows Terminal preview. So what it lets you do, this Windows Terminal lets you do tabbed interactions at a command line with both Windows Subsystem for Linux as well as PowerShell or a command prompt. So you can see here the choices of opening new things. I've got both Ubuntu 20 and Ubuntu 18 running. We're using 18 right now. So what I'm going to try now is, hopefully this will work. And it's not liking my OpenJDK AMD, because that's what my Java home is. So this is always where it goes badly. Maybe give me 1 second. Let's try this again. Maybe we didn't actually get it installed. And this is frankly part of why Hadoop has had challenges. First of all, it's difficult to get it up and running. Secondly, it's tightly coupled to Java. And Java, you'll notice I'm using OpenJDK here. That part of the reason for that is that the licensing related to Java has gotten very complicated, and you're having to like pay now as an organization. There was a time that you could pretty much use Java for free. That's no longer the case. OpenJDK is kind of the alternative to that. So the idea being that you can use it as an organization and not have to pay. Clearly, I either missed this command or there was an error. I ran it the last time. And that's, again, part of the reason why I wrote this script, was to try to get it to where this was less of a concern. But as soon as this completes, we should be able to kick it off. And again, I may pick this up next week if this doesn't go really swimmingly, as they say, because we've got 1 or 2 things left to do here. So basically, our next steps is going to be to initialize essentially the file system. So HDFS, like any kind of disk, is essentially unformatted when you first do it. So there's no folders, so to speak, no file system in place. So what we're going to do is format it so that we can then put some files onto it, and hopefully this will wrap up here shortly. I'm going to pause the recording for one moment while this is doing its thing, so you're not sitting here watching. Okay, finally finished, so we can step through the next few things. Let's try our all stop again. What this is basically doing is telling Hadoop to stop all of the services that might have been started earlier. And this is so that we can go through, and the next step will be, it does look like it's working. The next step is to go through and format our name node. And this is basically, try it one more time. All right. What is it not liking? This is always the fun part of live demos. So it may not like this. Let's see, so HDFS is working, HDFS, name node, format. That looks like that might have worked. Let's see. Next thing we typically do is start everything back up. This doesn't matter too terribly much, but we'll go back up here once it finishes starting everything up. And then our next step is to go through and create inside of HDFS a folder. And that worked, which is good. So the next thing is we're going to create a folder for me, and it'll use the who am I sort of variable. So it's basically creating it for me. And so at the end of it, if we do a list of /user, you can see there's /user /Alan. That means that it actually did work. So our next step is to run a Hadoop word count. Word count, as we've talked about, is just like the name implies, basically counts the words that exist. And so what we're going to do is make a directory called word count underneath my home, go and download a file. This is a Java file that actually does the word count. And if you want to see, this is basically what it is. Import. And this is pretty much the hello world of MapReduce programs. This is the one you see pretty much all the time. Then the next step is to pull down a text file so we can actually count some words. In this case, we're going to do Shakespeare's Summer Day. And then here the next thing is to put that file into HDFS. This is actually copying it up to HDFS. And so if we were to do an HDFS-ls, we should see that file in input. Okay, so we actually put it up into the input folder. Now we actually run it. So we're going to do Hadoop. This is basically doing essentially a compile. And then we can run the class. I'm going to go ahead and cheat. There's another step in here where you actually do the compilation, but we're running late on time. So I'm going to pull down the class file, which is what would be produced had that Java C actually worked. Now we're going to run the jar, or create a jar from that class, and then actually run MapReduce. And didn't work. All right, what do we got? Should have worked. Well, unfortunately, we're kind of getting close to another appointment. So, I believe it or not, I actually have got this working, and it's always fun to try to do it live because it's likely something simple that I've missed. One of the things that, if you're so inclined and want to get ahead, so to speak, up on my YouTube channel, you can watch the video that actually does work, and I'll actually include that whenever I post this. So with that, I'll wrap this up. As always, if you have any questions, let me know. Stay safe, and we'll talk again soon.